one solution. Anybody have another one? Might be useful.
Yeah.
Alright, anybody else? I see a lot of people not writing, so that would imply they have an answer, right, Evan? Ben, Liam, you didn't get an answer at all?
No,
Why not?
I don't know what to do.
Gaussian elimination. Maxine, did you get an answer? Okay, what'd you get for A3?
I have -2.1.
You don't have it in fractions?
No.
-2.1.
0.5 2.64. Negative 4.8. 4.34.
Okay. You're disappointing me, man. I thought you'd have an answer.
I was missing for half of last class, so.
This is just Gaussian elimination.
Yeah, I have an excuse.
No, you don't.
Yes, I do.
No, you don't.
Yes, I do.
No, you don't.
No, I do.
No, you don't.
No, I do though.
Well,
Miss Madden said I do.
can't argue with Ms. Madden, but no, I take exception to that. This is just a system of linear equations. Should be able to solve. How we got those is a different story, but once you have those equations, you should be able to solve that. Anybody else? Connor? Come on, man.
Paper's not looking good over here.
What'd you get?
I don't have an answer. I've been waiting to see how you do it, cause I didn't do it right.
Joe?
The answers don't match up at all.
Well, good, actually. What'd you get?
2.57,
Back to decimal.
negative 0.36,
36.
negative 1.53, 1.32.
Anybody else? Sean?
Still not right.
How do you know you're not right? He hasn't said what the answer is yet.
Because I'm putting it into my calculator and not getting the answers.
This is kind of perplexing. This is a relatively simple system
It gets,
that I put together yesterday off the top of my head, but with simpler numbers. And the other section had no trouble with it. Maybe if I had said that at the start, that would have got some of those competitive juices going.
oh, you're gonna do it?
I wasn't planning on it.
Just, I would not.
But, 1, 1, 1, 1, I'm just gonna set it up. 8, 4, 2, 1. 27, 9, 3, 1, 3, 64.
So you didn't understand how we got the numbers.
Yeah, I have no idea how he set it up.
4,
This time.
1, 2. So that's your augmented matrix,
That makes a lot more sense.
right? Hopefully you realize 2 cubed is 8.
Yes.
So that's the augmented matrix, and from there, the Gaussian elimination should be no different than what you've been doing for a while now, except the numbers are a little bit bigger, perhaps. All right, well, let me give you the answers, so then you can try and do it on your own. This is something you all should be able to do, and it's really not that difficult. All right, so the answers are, ready? 2/3. 6. 49/3. -10.
Okay, I had -10 and 49/3.
Okay.
I don't know what went wrong from there though.
Well, as you move up, you're gonna be solving, you get more in the equations, right? So these are the answers. So I would recommend you verify that for yourself. And the reason I didn't want to do this is because you should be able to do this, and B, I don't wanna spend the time. Because this part here was just an exercise in Gaussian elimination, and everybody should be able to do that. So, but the point of this is within the context of what,
I think I know why we were all wrong.
okay, I'm all ears.
It's the Friday before Memorial Day weekend, and it's the first period.
Yeah, no. If this was 5th period, that argument might have a little bit extra weight to it, but this is 1st period on a Friday. So,
My phone got it right, so they get an A.
your phone got it right. Well, if your phone can do it, you can do it.
I can't do simple math, that's why I got this wrong.
Well,
I just did it again and I got -6.
well, I mean, you got the -10 and 49/3, right? And as I said, when you go up and back substitution, now you got the 3rd equation with a sub 2, a sub 1, a naught, right?
Yeah.
So, all right, so, but the point is twofold. One is that's a system that should be easily solvable. 2 is now we have our interpolating polynomial, which is 2/3 x cubed plus, well, minus 6 x squared plus 49/3 x minus 10. All right, so that's our interpolating polynomial. So listen up now, everybody. So within the context of this problem, I would ask you a question that says, okay, assume this is our interpolating polynomial. All right, remember the context of this is that these are our data points, okay? And that polynomial now goes through these data points. That's what the theorem guarantees, and that based on those coefficients, that should be true. And the question then would be, well, what if you wanted to know what the output would have been, or what the data would have been? You're gonna make a prediction based on this polynomial. What it would have been for x equals 3x. That's, what was it?
Mr. Brennan, he's always so loud.
That's the question, right? So what would you do? Well, you would evaluate the polynomial at 3/2. That would equal 2/3 times 3/2 minus 6 times 3/2, and this is cubed, squared plus 49/3 times 3/2 minus 10. All you're doing is function evaluation for a particular value of x. So what would this be? Well, this is actually quite nice, right? So this is 3/2 cubed. So that's 3/2 times 3/2 times 3/2. So one of those 3/2 with this guy becomes 1. So all we're left with is 3/2 squared, which is 9/4, minus, well, this is 3/2 times 6. Is 3/2 times 6 don't tell me, 9 times 3/2 is 27/2 plus 49 halves minus 10. So put that under a common denominator, we get 9 minus 54 plus 98 minus 40 over 4. Is that right? And so this becomes, don't tell me, this is 107. This is 94. Minus is 13. 13 fourths. Now, I just did that bloody thing in my head here. And if I can do that.
Math.
Yeah, but I always say I'm not good with doing that arithmetic and such in my head, but look, you notice the logic I use, right? 3 halves cubed, so one of those 3 halves multiplied 2/3 is gonna make it 1. So that made it simple. Same thing here, one of those 3 halves times 6 is gonna make that 3, so, you know, I simplified it, but this is what it would be. So what does that mean? So here's here's 3 halves. So we said 13 fourths. I still have a senior who does proper fraction, whatever that stuff is. Like that's what,
A mixed number.
3 1/4. Right, I hate that. 1, 2, 3 1/4. So it's up here. So that's the point right there. So that seems like a reasonable prediction. So that's the whole point of this exercise, was to give you a different context of how Gaussian elimination can be useful for solving system of linear equations. And this context is this idea of an interpolating polynomial, which, trust me, is something that is used a lot. And I just wanted to expose you to the theorem and how to find it. And so you can expect a question that's manageable in terms of finding these types of things, but also important along with that is, now that you have that polynomial, what are you gonna do with it? Well, you're gonna use it to make predictions about what data points would have been had it been collected. Now, if we went out here to 5, that's extrapolation, right? That's extrapolation. And can't be too confident in those, because this data might have just started doing something funky after that. Does everybody understand at least the context of it? And does everybody understand, I was hearing some mumblings back, what did you have trouble setting up the matrix?
I didn't realize we had to, like raise the 2 to the 3rd power. That's for 2. Yeah.
2, 2, 2.
Yeah, that's why I was confused.
Well, what do you think this little 3 here was for?
I kind of just blocked it out of my mind.
I also did the same.
Okay, well, that could make a difference.
The matrix was all zeros.
Yeah.
I did the same thing.
Seriously? You forgot that this is 8 and
Yeah, I was just going like it was a normal, like what we had been doing last week, and I just completely ignored the degrees.
well, that would have caused.
Yeah, I had way too many zeros, and I was just
Yeah,
like,
yeah,
I
well,
didn't know what to do.
because the first row would have been all 1s.
Yeah.
The second row would have been all 2s except for 4 at the end.
Yeah.
And if you do elimination on that, you're gonna get zeros. You're gonna get a false solution, so, yeah.
Can you explain again how you got x equal 3 over 2 and like how?
Okay. I picked it.
Oh yeah. And then what's the number 13 over 4 like what is mean? Like what is mean in the thing you
Context. This 13 fourths within the context means that if data was collected at 3 halves, this is what the output would have been. Right? That's the purpose of this interpolating polynomial, is that we only have, this is our real data, right here, right here, right here. That's our real data. We don't have any other data, but we're interested in saying, well, I really wanted data for 3 halves, but it's not there. So we're using this mathematical model as a way to estimate or predict what it would have been had the data been collected. That's the whole point of this policy. Is that okay? Everybody understand the context of this problem? Yeah, so please beware of those little, they're there for a purpose, right? So. All right, so, well, since it is Friday, day before Memorial Day weekend, I want to get into one little extra topic briefly, and then next week sometime we're gonna have some kind of assessment, probably a test. And then that will bring us to the conclusion of the year. And the remaining time, I'll open the floor up for questions about the final. And maybe, and how I'm gonna, I still haven't figured out the exact way that's gonna work, but. So there's one other thing I wanna talk about, and that's summation. I'll just expose you to that, but that could wait till Tuesday, I suppose. So, taking Luke's argument as the esteemed politician that he is, you only got like 5 minutes left. So. But this is something everybody should do, and I'm sure that Evan back there, Liam, Connor, will never forget to raise those numbers to the experts. Did anybody else not do that?